Okay, in today's lecture, we shall discuss about non-blocking assignments. So, with few examples, we will discuss about these non-blocking assignments. In last lecture, we discussed about blocking assignments. In case of blocking assignment statement, we have seen that uh, the the blocking statement blocks the execution of the remaining statements. First, the current statement should be executed, only then the next statement will execute. So now we will see this non-blocking statement. Now here, the general syntax of non-blocking assignment statement is just similar to blocking assignment statement syntax. Only difference you will find here. This is the symbol of assignment, right? Whatever is at the right hand side, this expression is evaluated and the value will be assigned to left hand side variable, right? So this symbol is the assignment symbol. The less than equal to, this symbol is used to specify blocking statements. uh, Sorry, here this is not blocking, this is non-blocking non-blocking statements. The non-blocking assignments statements execute concurrently. So here the feature of concurrent execution of the statements will come in the picture. Means parallelly the assignment, all the non-blocking assignment statements will execute. Whereas in case of blocking assignment statement, we have seen that the statement execute in a sequence. First statement which is there in the order, that will be executed first, then only the second statement will be executed. And after that the third statement will be executed. But here all the non-blocking assignment statements execute parallelly, concurrently. The value will be assigned to left hand side only after the execution of all statements in a block, right? So the meaning is, suppose there are these three statements: statement number 1, statement number 2, and statement number 3, and these are non-blocking assignment statements, right? These are non-blocking assignment statements. Suppose on the left side we have the target variable like x, y, and z, right? So here what will happen? All these three statements will execute concurrently. So whatever expression is there in the statement 1 at the right hand side, in this side at the right hand side, this expression will be evaluated, and at the same time the expression of the right hand side of statement number 2, this will also be evaluated, and the right hand side expression of statement 3, this will also be evaluated. So this right hand side expression of all these three statements will be evaluated at the same time, and the values will be assigned to the target signal x, y, z at the same time, right? So here it is now, if suppose these are the blocking statements, then what will happen? First statement 1 executes and the value will be assigned to target signal s. After that only statement 2 will be executed, and once when the statement 2 is executed, at that time the right hand side expression value is evaluated, and that evaluated value will be assigned to y. After the updating the value of y, then only statement 3 is executed. But here in case of non-blocking statement, all these three statements execute parallelly. It will not wait for the updation of the value at the left hand side, right? All will execute parallelly. Okay. Now this is the recommended style for modeling sequential logic. So normally to model a sequential logic we can use these statement, but it is not like that. We cannot use these statement for the sequence for the combinational. That is also possible, but normally it is used for sequential logic. Okay, so now we will see one example for non-blocking assignment statement. This is example one. Now, this example just to one means I have taken here the initial block to explain the non-blocking assignment statement, and we know the property of the initial block that it execute only once, right? So here there are three integers a, b, c. This is the initial block number one, and in initial block number one we are using blocking statements, right? We are using here blocking statements. These are blocking statements. So here 10 will be assigned to A, 20 will be assigned to B, and 15 will be assigned to C. Then there is a second initial block. This is the second initial block. In this second initial block, the first statement is B plus C is assigned to A. Then the second statement is A plus 5 is assigned to B. And third statement is A minus B assigned to C. And these three are non-blocking assignments. These are non-blocking. Statements. Okay. So now all the right hand side expression will be evaluated concurrently by using previous values of A, B and C, and the evaluated values will be assigned to left hand side together at 5 unit time. Okay, this is not 5 unit time. Here, see, here we have not used any this time delay. So I will use in next example. So by mistake it is written for basically for example number 2. So this is not right. So here you just see what will happen here. When you run this code, then the value of A, B and C will be initialized as 10, 20 and 15, right? So initially A is equal to 10, B is equal to 20 and C is equal to 15. And due to the initial block 2, when this is running, now you see statement 1, statement 2 and statement 3 are executing in parallel, right? So due to the statement 1, B plus C will be evaluated. So what is the current value of B? Current value of B is 20. What is the current value of C? Current value of C is 15. So 20 plus 15 is 35. So this evaluation is done, but the value 35, evaluated value 35 is not assigned to A. Only evaluation is done, right? Now since statement 2 also executes parallelly, and here due to in the statement 2, A plus 5 will be assigned to B. So what is the value of A? Here the value of A is 10, because in statement 1, only evaluation of B plus C is done, but the A is not updated. That's why when A is used in statement 2, at that time, previous value of A will be used. So previous value of A is 10, right? So 10 plus 5 is 15. This evaluation is also done. Now the third statement is also executing parallelly with statement 1 and statement 2. Now the statement third is B, this A minus B assigned to C. Now here, since the A in statement 1 is not updated, B of statement 2 is also not updated. That's why in statement 3, the previous values of A and B are used. So previous value of A is 10 and B is 15. Sorry, B is 20. So 10 minus 20 is minus 10. So this evaluation is also done. And once the evaluation of all these statements are done, then only the updation will take place, right? So A becomes 35, B becomes 15, and C becomes minus 10 after the updation. Okay. So this is about the blocking assignment statement. I will just show you the results of this particular example. I will run this in the software and show you the results. Okay. So this same code I have pasted here, right? This, and now I will check the syntax of this code. So here, process behavioral check syntax completed successfully. So there is no error, syntax error. Now I will simulate this code. Okay. So here you can see at 0ns. At 0ns, all these three statements of means these, I will show you this. These statements, right? All these three statements execute exactly at 0ns. Okay, and after the execution, the values will be updated to A, B, and C at the same time, right? But when the evaluation of B plus C, A plus 5, and A minus B is taking place, at that time the previous values of A, B, and C are used, right? And the evaluated value will be updated to the left hand side variable after the execution of these all three statements, right? So here now we will see the result. So A should be 15, A should be 35, B should be 15, and C should be 10. So A should be 35. So you see here what is the value of A. Here A is so in 32 bits the result is displayed because already we know that the default values for the integer type is 32 bits. So here you see here 1 0 0 0 1 1, and after this one all are zeros. So from here we can calculate 1 0 0 0 1 1. So this is A is 1 0 0 1 1, and all remaining these higher order bits are 0. So this is my bit number 31 and this is my bit number 0. Bit number 0, bit number 1, bit number 2, bit number 3, bit number 4, bit number 5 and bit number 6 like this. So what is the value for this? So here the weight for this LSB1 is 1, for next one is 2, and for this one is A16. Okay, 1 0 0 1 1. So something is missing here. Actually for 35 it should be this. It should be 1 0 0 0 this is this weight is 32, right? 32 and 1 1. This 32, this is 2 and this is 1 weight. So it will be 35. So answer should be 1 0 0 0 1 1 and remaining bits are 0. It should be 0. So 1 0 0 0. So here I think by mistake I have written here. This should be 1 0. This should be the answer. 1 0 0 0 1 1. We'll check there. This is 35. So it is 1 0 0 0 1 1. Yes, this is 35. Now for B. For B it is last 4 digits, 4 bit positions are 1. So last 4 bit positions are 1. It means that it is 1 1 1 1 and remaining bits are 0. So the weight of this one is 8, this is 4, this is 2 and weight of this one is 1. So if you add all these then it is 15. So this is for B, and C is minus 10. And already we discussed in the last lecture when we discussed about the blocking assignment statement that for a negative number the result will be represented in 2's complement form. So if you want to find out what is the actual number, so you convert that 2's complement value in 2's complement form, then you will get the result, right? So we will see the value of C. So here C is, see all are these 1 and last 4 digits are 0 1 1 0. 0 1 1 0. This means the result is 0 1 1 0 and remaining all are 1. This is bit number 31 and this is bit number 0. So total 32. So here this 1 MSB at the 1 indicates the number is minus. Okay, it is in, and it is represented in 2's complement form. So if you want to find out what is the magnitude of this number, then what you do, you convert this number in 2's complement form. So what will be the 2's complement of this? So first we will convert in 1's complement. So here it is 0 Here all bits are, since all bits were 1, so here you will get 0 up to here. Then for this 0 it is 1, for this one it is 0 and 0 and 1. This is 1's complement. This is 1's complement. And for getting 2's complement, you add 1 in this. You add 1 in this. What is the result? 1 plus 1 is 0 and 1 carry is generated. And that 1, 0, 1 and all are 0. All are 0. So this is the magnitude of this negative number. So what is this number? So this number is 10. 10 is the magnitude, and you put minus sign in front of this. So this is the result. So exactly this is the value of C, minus 10. Right? Okay. Now we will see another example, example 2. Here also we have used two initial blocks. Initial block 1 is used for assigning the values to A, B and C integer type variable by using blocking assignment statement. Now in this initial block 2 we are using here the non-blocking statement. So here the values of A, B and C are initialized with 10, 20 and 15. When the initial block 2 executes, at that time these statement 1, 2 and 3, these three statement executes exactly at the same time. B plus C will be evaluated and the result will be 35. A plus 5 is evaluated, and here the value of A, whatever is the previous value, this will be used, not this value, means 35, because this updation is not completed here, only evaluation is done. So A plus B is 10, A plus 5, 10 plus 5 is 15. So this is also evaluated. Here this is evaluated as 35. Here it is evaluated as 15. This is 15. And A minus B is evaluated as minus 10, right? But in last example, here see these code. Here these three values which were evaluated, after the evaluation of these three, which is done in parallel in concurrent way, the updated values will be assigned to A, B and C exactly at same time. Means at 0 ns the evaluation will be done. At 0 ns means when the simulation starts. Simulation starts at 0 ns time. At 0 ns evaluation will be done, right? Evaluation of right hand side, right? Right hand side of statement number 1, 2 and 3 done. Okay, and again at same time at 0 ns the updation of left hand side of statement 1, 2, 3 done, right? But now you see in this example 2, here we have used hash 5 and hash 5. The meaning of this hash 5 is evaluation is done at 0 ns, but this evaluated value will be updated to target signal A, B and C after 5 unit time. If suppose the unit for the time we have taken 5 nanosecond, then after 5 nanoseconds only the updation to A, B and C. Updation to this, yes, A, B and C will be done, right? This is the meaning of this code. Because we have used the delay here for the updation. Okay. So I will just demonstrate you this particular code also. Results are same, means A will become 35, B will become minus 10 and C will become B will become 15 and C will become minus 10. But the updation will take place only after 5 unit time, 5 nanoseconds. So I will change this code. Okay. So this is a new code of example 2. Now first I will check the behavioral syntax. Okay. Now I will simulate this. So you can see here, right. Now see, this is the 5 nanosecond here. See, this is a 5 nanosecond. Before 5 nanoseconds, what are the values of A, B and C? These are the values of A, B and C due to first initial block, due to this, because you see this initial block, A will be assigned a value 10 at 0 ns, B will be assigned a value 20 at 0 ns and C will be assigned a value 15 at 0 ns. Okay. And the blocking statements of initial block number 2, they will also execute at 0 ns, but in the initial block 2, the updation to A, B and C takes place only after 5 nanoseconds. But in initial block number 1, the updation will take place exactly at 0 ns, right? So you can find the value of A is 10, B is 20 and C is 15. This you can find at 0 ns, right? So you see this result, A. What is the value of A? A is 100011. So what is this 100011? It is 32 plus 35. A is 35. So you can see here, no, 1 minute. A is not 35. Here you check this, right? Before 5 ns, we have to see before 5 ns, at 0 ns, what will be the values? So value is 1010. A is 1010. So what is the 1010? It is 10. What is the value of B? It is 10100. So this is 16 plus 4 is 20. So B is 20. So you can see here B is 20 and C is 15. So you can see here C is last 4 digits, you see 1111. So this is 15. Now at 5 ns, due to the initial block number 2, new values will be assigned to ABC. So what is the new value to A at 5 ns? It is 100011. And what is this 100011? Already we have calculated earlier. It is 32 plus 2 plus 1. 35. So A is 35. B is 1111. B is 15. So you can see B is 15 at 5 unit time. And C will become minus 10 at 5 unit time. So you see the value of C. It is, see the MSB. MSB is 1. This indicates number is negative. and it is represented in 2's complement form. So if you convert this number in 2's complement form, then you will get the magnitude of the number. And if you put the negative sign in front of that, that will be the representation of that number. So it is 10. So now I hope you have understood about this blocking assignment statement, non-blocking assignment statement. In previous lecture, we discussed about the blocking assignment statement. So now you can differentiate between these two types of assignment statement. And right. Okay. By this, I will conclude this lecture now.